Hi there, welcome to brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Today's lesson is taken from Brilliant Maths Module 8, so get a copy of the book and let's go to class. In this lesson, we're looking at Introduction to Vectors. What is a vector? A vector quantity has direction and magnitude. The magnitude of a vector is the length or the size of the vector. Examples of vectors are forces and velocity. A scalar quantity has magnitude but no direction. Temperature is an example of a scalar quantity. AB, vector AB denotes the directed line segment representing a movement from point A to point B. So vectors are denoted in this form, written as A, B in capital letters with an arrow showing the direction. A vector is also a two-dimensional movement given in the form xy, so that where x is the horizontal movement, that's the movement you make horizontally on the plane, for example, and then y is a vertical movement up and down. So when you move from left to right, it is positive, and from right to left, it is negative. If you go from top to bottom, coming down, it is negative, but if you go upwards, it is positive. Consider the vector AB as a movement 1, 3. That means that the vector AB starts at a point A and moves 1 unit horizontally. So it starts at a point A and makes 1 step movement horizontally, and then 3 steps upwards. So the first one on top is the x-axis, and the second one is the y-axis, horizontal and vertical movement. So the vector AB starts at point A and moves 1 unit horizontally and then 3 units vertically. This is represented in the diagram below. So the vector we're actually talking about is the movement from A to B. So you can see the direction from A to B. But how do you get to B from A? You first of all make 1 step movement on the horizontal axis. So 1 step horizontally and then 3 steps vertically upwards. If the vector AB is equal to xy, then the vector BA, you can see that the letters are reversed. From this time, you are going from B to A. BA is equal to minus AB, which is equal to minus x, comma, minus y. What I mean by that is, if that is our AB, assuming that is AB, you can see the arrow from A to B. In BA, the arrow will be in the opposite direction. So that is AB and that is BA. And when the directions are different, then they negate each other. It's called the inverse or the negative vector of AB. So BA, vector BA, is the inverse or the negative vector of AB. Let's look at vector addition. We have the parallelogram law of vector addition, where you can add 2 vectors together. So let's consider the vector OA and vector OB. Using the parallelogram law, we have vector OA and vector OB. So we complete a parallelogram to add both. So OA is A and OB is B. So to complete the parallelogram, we draw the other 2 sides, which is BC and AC. But we note that OC will be equal to OA plus AC. But AC is equal to OB. So we replace AC with OB. so that we have OA plus OB is equal to OC. So that's saying that to add these two vectors, using the parallelogram law, complete a parallelogram, and then use OB instead of AC. This is a law that will need to work with vectors, that OA plus OB, which is the same as our AC, is equal to OC. So please take note of that, so that our OC is equal to vector A plus B, because OA is A and AC, which is the same as OB, is equal to B. So please take note of that. This is used to add two vectors. And this parallelogram law for adding two vectors can be extended to adding two or more, three or more vectors. So in a case where we have a polygon, for example, consisting of AB, BC, CD, and DE. So to close up from beginning to the end, we have a polygon, we have a five-sided polygon, that's a pentagon, such that vector AE is equal to vector AB plus vector BC plus CD plus DE. So to go from A to E, you go all the way round. This is an extension of the parallelogram law because we have established that AB plus BC is equal to AC. We had already established that. So using that concept, we have that AE is equal to A plus B plus C plus D. I hope that is clear. Then let's look at multiplying by a scalar. Ordinary numbers are scalar quantities. Scalar quantities have only magnitude. They don't have direction. So when a vector x is multiplied by 2, the result is 2x. You just double the vector. So assuming vector x is, let's say this is about 12 centimeters, then vector 2x is just 12 times 2, which is 24. And they are in the same direction. But the vector minus 3x is in the opposite direction and is 3 times the vector x. In this next example, as you can see on your screen, the grid is made up of identical parallelograms. The position vector of A is from the origin to A, from O to A, and is equal to A. And the position of B, the position vector of B is B. That's our OB. So we're going to move in steps of A or B. A going horizontally and B going vertically. So let us try to write down the following vectors in terms of A and B. So let's look at OG. OG, you can see that you go 2 steps in the direction of A and then 1 step in the direction of B. So the vector OG is 2A plus B. Keep your focus on the screen. Keep your focus on the grid. The next is OS. OS, you're going to go 3 steps in the direction of A and then 3 steps in the direction of B. So the vector OS is equal to 3A plus 3B. The next is the vector CL. The vector CL is simply going 2 steps in the direction of B. So CL is equal to 2B. Can you try to work out the vector CP? You'll go 2 steps in the direction of B, and then 1 step in the direction of A. So that gives us 2B plus A, or A plus 2B. The next is the vector CH. To go from C to H, you have to go backwards in A, in the direction of A. 1 step backwards in the direction of A, and then 2 steps in the direction of B. So So the vector CH is actually minus A plus 2B, as you can see. The next is the vector BH. To go from B to H, you go one step in the direction of A, and then one step in the direction of B. So that is A plus B. Let's look for the vector BQ. BQ is 2A plus 2B. And then finally, we're looking at the vector TI. From T to I, you're going to go 4 steps backwards in the direction of A. So the answer is minus 4A. That is very interesting. You can get more exercises from Brilliant Maths Module 8. So let's look at vectors as translations. All right? Example 1. Find the vector for the translation which takes the vector 2, 5 to 6, 4. Find the vector for the translation which takes 2, 5 to 6, 4. We want to find that vector. We just want to know the distance that it has moved from 2, 5 for it to become 6, 4. So you subtract 2, 5 from 6, 4. So it becomes 6, take away. We simply subtract. 6 minus 2 is 4, and 4 minus 5 is minus 1. So that vector is 4 minus 1. In example 2, it says the translation has vector 3, 2. Where does the translation take minus 4, 5? Where does it take the vector minus 4, 5? In this case, we are adding the vector translation to the vector we have so that we know the new position. So we add that, so it becomes minus 4, 5 plus 3, 2. So minus 4 plus 3 would give us minus 1, and 5 plus 2 would give us 7. So that translation vector would take the vector minus 4, 5 to minus 1, 7. This is actually very easy. Get some more practice from Brilliant Maths Module 8. So here we want to look at equal and parallel vectors. When are 2 or more vectors said to be equal? Or when are 2 or more vectors said to be parallel? 2 vectors are said to be equal or equivalent if they have the same magnitude and direction. That is, if they have the same size and in the same direction, then they are equal. In terms of components, 2 vectors are said to be equal if their corresponding components are the same. So for example, if vector A, the components xy, and vector B has components kh, then for A and B to be equal, it implies that x is equal to k and y is equal to h. Try this out. This is an example we'd want you to try out. If A is equal to 3x plus 1 and 2y plus 3, those are the components of A, and B is equal to minus 8, 5. Those are the components of B. Find the value of x and the value of y if A is equal to B. We want you to try this out, and you can get the solution from Brilliant Maths Module 8. Parallel vectors. Vectors are parallel if they have the same direction. So if they have the same direction, they are parallel. The component of one of the vectors must be a multiple of the other. So the component of one of the vectors must be a multiple of the other vector. So in general, the vector AB is parallel to the vector KAB, where K is a multiple of AB. So what do we mean? Vector 4, 6 is parallel to the vector 2, 3 because 4, 6 can be written in the form 2 into 3, 2. You can scale this down. 2 is common to both components, the x and y. So you divide both components by 2, and then the 2 becomes the scalar multiple, so that the two vectors, 4, 6 and 2, 3, are parallel. That's how simple the concept of parallel vectors are. In this lesson, we want to look at addition and subtraction of vectors. Then, talking about column vectors, we know what they are already, but we just want to emphasize it. The vector AB written as a column vector is written as 2, 5, where 2 is the horizontal movement and 5 is the vertical movement. X, Y, and the vector CD, these are all column vectors. Then resultant vector. What is a resultant vector? A resultant vector is the result of adding two vectors. The result of adding two vectors together. So assuming a man moves from point A to B, that movement describes vector AB. Then he moves from point B to point C. So that other movement describes the vector BC. Then next time he decides to move from point A straight to C. AC is a resultant vector. Instead of coming through B, it goes directly from A to C. So AC is a resultant vector. So we have that AB plus BC is equal to AC. That is a rule that you need in working with vectors. The resultant vector, take note, has two arrows. So instead of coming through B, where you go from point A to B and from point B to C, it just means going directly from A to C. Example 1. Given that the vector AB is equal to 2, 1 and vector BC is 3, 5, find AB plus BC. Vector addition and subtraction follows the same rules as addition and subtraction of numbers, positive and negative integers. So the solution, vector AB plus vector BC, we just add the components together. Add the horizontal components or the x components and then the y components. So 2 plus 3 is equal to 5 and 1 plus 5 is equal to 6. So AB plus BC is equal to 5, 6. Example 2. Given that PQ is 5, minus 2, and QR is 4, 1, find PQ minus QR. Follows the same principles. PQ is 5 minus 2, minus QR is 4, 1. So let's write that out. I'd like to work it out. So 5 minus 4, 5 minus 4, and minus 2 minus 1. So minus 2 minus 1. So that our answer becomes minus 1 minus 3. So like I said earlier on, the addition and subtraction of vectors follows the same principles as addition and subtraction of integers. In this lesson, we want to learn how to find the magnitude or the modulus of vectors. Modulus is the same as magnitude. The magnitude or modulus of a vector is its length. That's the size of the vector. And it is written in this form. The vector with the modulus signs by it. So for example, find the magnitude of the vector AB. And the vector AB is equal to 3, 4. So what that actually means is you're moving from point A to B. So assuming you're at point A, And then you move 3 steps in the horizontal direction to the right because it's positive. So we'll go 3 steps, and that's 3. Then 4 steps upward to get to B. So that's our point B. So we're looking for the length of that line. So to find that line, many of us should be able to recognize this line as a hypotenuse when you are working with Pythagoras' theorem. So it's the same formula. To find that length, AB, the modulus of AB, is the square root of the square of 3 plus the square of 4. So square of 3 is 9, and the square of 4 is 16. 9 plus 16 is 25. So the square root of 25 is 5 units. So the magnitude of vector AB in this question is 5 units. Example 2. Find the magnitude of the vector A plus B, where A is 3, minus 2, and B is minus 7, 5. So how do we work that out? Let's see. So we said that A plus B is equal to so we're adding the 2 vectors together, following the same principles of addition of integers. So 3 plus minus 7 would give us minus 4. And minus 2 plus 5 will give us 3. So to find the modulus of AB, modulus of AB is equal to the square root of minus 4 squared plus 3 squared. Minus 4 squared is 16. 3 squared is 9. So again, we have the square root of 25, which is equal to 5 units. Please, modulus is not always 5 units. This is just a coincidence that the first example and the second example have the modulus as 5 units. But look at this. Given that the vector LM is minus 3, 4, and MN is minus 15P, find the vector, find the modulus of LM, and find a value for P if the modulus of MN is equal to 3 times the modulus of LM. Take your time. I'd like to read the question again. Given that the vector LM is equal to minus 3, 4, and the vector MN is equal to minus 15, P, find the modulus of the vector LM, and then find a value for P. P is unknown here. Find a value for P if the modulus of MN is equal to 3 times the modulus of LM. That's very interesting. Try it out, and you can get feedback from Brilliant Maths Module 8. In this lesson, we want to look at position vectors. A position vector is a vector which starts from the origin. The position vector of the point A with coordinates xy is a vector OA xy. So for example, if we have a vector 2, 3, the position vector of 2, 3 is column vector 2, 3. It starts from the origin. So note, if A and B have position vectors A and B respectively, then AB is the position vector of B minus the position vector of A. Please take note of that. Let's look at it from the example. So we have vectors A and B. So that's OA and that's OB. What we're trying to say is that AB from A to B is minus A plus B. And minus A is actually minus OA. Do you get that? OA is A. But minus A will be minus OA. So that we can say that AB is OB minus OA. So take note of that. That's very important. You need this to work with vectors. Then, let M be the midpoint of AB. So we have the vector AB, and M is right in the middle. The midpoint of AB has position vector OM. Find that position vector. How do we find the position vector of the midpoint? AB, we have established that AB is, we're coming from A to B through O. So that is minus A plus B, which is the same as B minus A. In that direction, AB. So that means that BA will be minus B plus A. I want to establish that the vector AB is B minus A, and vector BA is A minus B. We've swapped the directions. Then the midpoint, just halfway, AM will then be half of AB. So AM is just half of AB. So that will be half of B minus A. Also, BM, swapping the direction, going from B to A instead of A to B, BM will be half of BA, and BA is A minus B. So BM is half of A minus B. So OM, the position vector of the midpoint, is equal to B plus BM. And we know that BM is half into A minus B. So that's what we have here, B plus half into A minus B. So we open up that bracket, we have B plus half A minus half B. So B minus half B would give us half B. So we have half A plus half B. So OM is equal to, the position vector of the midpoint is equal to half into A plus B. If you find OM going from O to B and then to M, you will get the same answer as if you find OM going from O to A and to M. You can try out that other direction. You will get the same answer. And the position vector of the midpoint is equal to half into A plus B. You can get more examples and more exercises from Brilliant Maths Module 8. Let's take a look at vector geometry. This is very interesting. You just have to pay attention. So focus. Example, given that the vector OA is equal to A, so the vector OA is equal to A, and OB is B, OB is B, AQ is equal to half A. So let's look at AQ. AQ is half A, but OA is A. So that means that OQ is 1/2 A, which is 3/2 A. So take note of that. So AQ is half A. BR is B. So that implies that OR is 2B. And then AP is equal to 2BA. AP is equal to 2BA. The first question says, express BA, that is BA, and BP in terms of A and B. So let's see how we can do that. Solution: BA is equal to minus B plus A. To go from B to A. So from B to O, so that's BO plus OA, which is minus B plus A. So we have done the vector BA. The next is vector BP. So BP is equal to BA plus AP. BA plus AP. And we know that BA is minus B plus A. And also, AP is 2BA. So, BP will be 3BA. And BA is minus B plus A. So that will be 3 into minus B plus A, or 3A minus 3B. So keep that. We've been able to express BA and BP in terms of A and B. So the second question is, express RQ in terms of A and B. Where is RQ? That's RQ. So RQ, there's no direct path. So RQ will be from R to B. That's the vector RB plus the vector BA. And we know that RB will be minus B because BR is B. So RB is minus B. And then BA, we have BA already as minus B plus A, or A minus B. So RQ will have RB plus the vector BA plus the vector AQ. And we know that AQ was given as half A. So RQ is minus B plus A minus B plus half A. So we simplify that algebra. Half A plus A. When you open the brackets, that will be 1/2 A, which is 3/2A. Minus B will give us minus 2B. So the vector RQ is equal to 3/2A minus 2B. We have also answered that question. We have expressed RQ in terms of A and B. So the third question, express QA, the vector QA and the vector QP in terms of A and B. QA will be negative AQ. AQ is half A, so QA will be minus half A. Then QP is going to be QA plus AP. That's what we have there. QP will be QA plus AP. And we know that AP was given as 2BA. And our BA is minus B plus A, or A minus B. So that's how it becomes 2A minus B. So AP is equal to 2A minus B. So that QP is minus half A plus AP, which is 2 into A minus B. So open up the bracket. So we have minus half A plus 2A minus 2B. Simplify. 2A minus half A will give us 3/2A. That is 1/2 A. All right? So that our QP is equal to 3/2A minus 2B. The last question. Using the vectors for RQ and QP, show that RQ and P lie on a straight line. That is very easy. In the second question, we were told to express RQ in terms of A and B. So we found our RQ to be 3/2A minus 2B. So we have that already. And then we also found QP QP to be equal to 3 over 2A minus 2B. So the two vectors are equal. So if the two vectors are equal, then they are parallel. And notice that Q is a common point. RQ and QP. So definitely the 3 points lie on a straight line because RQ is equal to QP, which implies that they are parallel. And since Q is a common point, then we know that R, Q, and P lie on a straight line. R, Q, and P. So this can as well just continue straight. Let me use a black marker just to show that lie on a straight line. So we have been able to show that using the vectors RQ and the vectors QP. You can get more of this from Brilliant Maths Module 8. Get a copy of it and you will be able to practice yourself to excellence. I hope you enjoyed all the lessons on vectors, right from addition and subtraction of vectors to finding the position of vectors, and especially vector geometry, where you need to pay a lot of attention. Get a copy of Brilliant Maths Module 8 and take advantage of all the resources we have for you at brilliantmaths.com. Subscribe, tell a friend to tell a friend. You will be glad you did. Always remember, maths is fun and you can excel in it.